So let me introduce me first. So I am Piyu. I work as a senior data engineer in Collabora for about 3 years now. So I have roughly around 10 years of experience overall, all in the data background, primarily in uh, ETL and then SQL, PL SQL, Unix shell scripts in the beginning of my career, working in big data technology for about 4 years right now. So mostly in the Azure domain. It's mainly on the migration of on-prem data solutions to cloud. So that's all about me, Aziz. If you could introduce yourself.
Hello, Piyu. I am Aziz. I have done my graduation from IIT Madras and I've graduated in 22. And since then, I've been working at Walmart Global Tech for about 2 years. So my job functions, basically, they were cross-functional. I kind of worked in the space between software engineering and data engineering, with more focus on the software engineering part as of now.
Mhm.
However, my primary interests lie in the data domain, be it data analysis or data science or data engineering, so to speak.
Mhm.
And yep, that is why that has been my motivation to apply for data engineering roles.
Got it. So if you can say about your tech stack, like what particular tools and technologies you use, and also
Primarily,
uh, sorry to cut you, and also
yeah,
if you could say along with your tech stack, like the business use case that you're trying to solve in your project.
sure. So primarily, I worked in the SEO domain for about 1.5 years, and our goal was to basically rank our pages in the top 5 or top 6 in every category. So in that aspect, we had a lot of keywords for which we had to identify whether or not the keyword were of retail intent or not. So we had an API wherein we made those API calls and populated for millions of keywords. What the retail intent of that keyword could be. So the tech stack basically we had was Python pandas for data processing. We had Google Dataproc for running Dataproc jobs. We had like the entire GCP tech stack, so to speak, but I kind of used GCP, Dataproc, and BigQuery extensively as compared to the other technologies. And yeah, there was SQL and Python, as I discussed earlier.
So like in
And the
your,
that
yeah.
yeah, I'll just reiterate the use case as well. So the primary focus was for us to get the number of visits and the impressions higher for every page of ours, and that was to be done by improving the page rank. So that was the primary focus of my work for the first year, my career.
Got it. So the transformations that you're using in your whole data processing, like what kind of transformation you use? Like, do you use Spark?
Uh, I kind of used Spark to an extent, but I
Mhm.
use Spark more or less in the interactive mode. I didn't have to use Spark, as far as running schedule jobs is concerned a lot. Um, but for what I typically did is I ran experiments,
Okay.
for sample data sets. So identified the data firstly in the Spark environment and then downloaded that in the local space. And once it was available for processing locally, I think I found it much more easier to use pandas to assess what the data is like, what the data sanity should be, and then maybe made incremental changes to, wherever I thought the data is incorrect or something.
Okay. So can you explain about the incremental method that you use? Like either the way that you handle in your project or like how it works in the CDC mode, like change data capture mode.
Um, uh, I didn't have a very formal approach to, changing the data per se. I just, did a lot of frequent interactions with my manager about what the possible data could be, what possible outliers could be. And
Okay.
apart from that, yeah, that the work revolved around, getting rid of outliers firstly. And secondly, there were obvious problems with, certain sources. For example, we had a lot of keyword vendors, SEMrush and Brightedge being two of the many. So a lot of times what would happen is we got inconsistent fields, what we desired for our final analysis. So we had to get rid of that incorrect data as well. For example, one of the major pain points that we had encountered is that for the search volume, all of the different vendors have a different metric to estimate what the search volume is for a certain keyword. So that gave us a lot of problems, standardizing that measure. So yeah, work revolved mostly around understanding what the business requirement is, what the business context is, and then aligning them with the skills that we have.
Okay, got it. So have you worked on any data warehousing projects, like where you have to keep the historical data as well?
Yes, we did have. We had a table which had a lot of keywords. I think the data set was close to around 20-25 GB. And that table, basically, that was our, I mean, it was our primary source of data for every analysis that we had. So that table was called the keyword data lake. And it is something that I hadn't designed as such, but I had used extensively for all of my downstream tasks. And in that table, I had the opportunity to tweak a lot of, Spark jobs in order to get the
Mhm.
output as quickly as possible.
Okay, so my question was little different. Like I was trying to understand, like if you have implemented slowly changing dimensions, like if you have an historical table, um, so how would you identify that a particular record for example, a customer or someone who is visiting your page has visited earlier and he is returning now again. So how would you distinguish that? Like, is there any particular way you distinguish it?
That's a great question. Maybe I haven't had the chance to actually work on such a problem in the past,
Okay.
but I think we can, walk through some of the possible solutions.
Yeah, sure. So what I was trying to portray is, for example, there is a table in your system called visitors.
Yeah.
Um, Probably it's a very huge table and it has millions of records. For example, there is one particular visitor who has visited a few days ago. So next time he visits, so your SCD should work in such a way that you'll have a new record for the visitor. So the old record would have the start timestamp and the end timestamp. For example, how long he was there in the page, uh, searching on something, doing some activities. So the start and the end time would be there. And next time if he visits again, so a new entry would be uh, inserted in your table with the start time as when he clicked the page and end time, for example, null, or you give a later timestamp. So in this case, I believe null would be appropriate. And then when he leaves the page, then the timestamp would get updated. Another approach would be to put another column setting like the active flag. So if that current record, like if he's visiting for the first time or right now, so just put yes or no, or one or zero as the active flag, and the previous record as no or zero, something like that. So the first approach that I told, it's like SCD type 2, like slowly changing dimension type 2. The next one is slowly changing dimension type 3. Sometimes there is a combination also, like you keep both the approaches. You have the start and the end time, also the active flag. It's like in our system, we use this mixed approach. And
Okay.
like SCD type 1 is like where you don't keep historical records. It's just like refresh of data. Every time it's a full load and the other records, like the older records, get wiped out.
Okay, I got a good understanding of, the slowly changing dimensions.
Mm-hmm.
To add to that, I'll just give you a context of how we actually treated data. So what we
Yeah.
had is we had a number of vendors, and the vendors, what they did is they gave us a few fields that were of interest to us. So definitely the keyword was of interest toward what we search on search engines. And apart from that, what they actually gave us is a monthly search volume and the monthly impressions and clicks. So we didn't have the, a task of dealing with visitors per se. Yeah, but yeah, I'll keep that in mind, whenever I have the opportunity to deal with,
Yeah.
visitors
Yeah,
as well.
and it definitely like depends on the situation, on the type of business use case you deal with. But yeah, this is like one of the common solutions that we would use in industry. Yeah.
Okay, I'll just reiterate for my own understanding. So
Yeah.
basically, in the slowly changing dimensions part two, what you basically mentioned is we have dedicated timestamps for when a user enters our system and when he leaves it, so that we can, based on the timestamps, we can distinguish what different sessions the user had on our web page per se.
Correct.
And the second one would be that we kind of not use the timestamp columns, and maybe for every active session, we create an active or a passive flag as such, right?
Yeah.
Okay.
So you said earlier that you used rankings in your project. So if I have to say, like, I am assuming that you have worked on SQL as well.
Yeah.
So like in SQL queries, do you remember such analytical functions where you used ranking?
Yeah. We have three precise ranking functions as such. One of them is row number, the second is rank, and the third is dense rank.
Mhm.
And they have slight differences, and they kind of do the same function, which is basically uh, perform ranking on a certain column of a database, of a table,
Okay.
sorry.
Yeah. Any difference between rank and dense rank?
Dense rank is basically you will not have holes when you actually look for rank. For example, if you have two entries which have the same value and you want to rank between them,
Mm.
so you will not have a situation wherein you run into 1, 1, and then you have 3 and 4. So you will have contiguous numbers as far as the ranks are concerned, and which is not there in the main rank function.
Got it. Um, have you worked with common table expressions?
Yeah, I've worked with common table expressions.
Yeah. Can you explain the concept?
So common table expressions, basically those, like the way I have used common table expressions, those are kind of the substitute for writing major subqueries that kind of logically you divide your whatever subtasks are there in order to arrive at the final answer. And
Mm-hmm.
common table expressions by design, they are to be, they are as such, we store the things in memory. And from that, suppose, for example, if you had to search something, you would store the expression in in a format basically wherein you can just retrieve it from memory, and then maybe you can perform the final whatever computations that you need. So you don't have to go through the headache of writing big subqueries. Now you do have to make dedicated saved queries as such.
Got it. Um, so like in your current project or past project, like whichever you have worked, what are the kind of file formats you have dealt with?
I've dealt majorly with JSON, CSV, and Parquet. Uh,
Mm-hmm.
and even in that too, I think most of our work revolved around Parquet. Wherever we
Mm-hmm.
had something, experimental to do, we were dealing with JSON or CSV. But
Okay.
wherever data size was pretty huge, by default, it was stored in Parquet format only.
Mm-hmm. So any like do you remember or know any advantages of Parquet over the other files? Like I know that you like one of the reasons you said that like when the volume is big, the data volume is big, you use Parquet. Other than that, you could tell any reasons for using Parquet.
Uh, the primary reason that we use Parquet, and this is before I had an understanding of the file format, is
Mm-hmm.
Spark has inherent support for Parquet, and basically it dovetails very well with the Spark environment. Whereas for CSV and JSON, as I mentioned earlier, the only reason that we don't use it for very big tables in our org is basically because when the size becomes too large, the compression becomes very difficult for those file formats.
Yeah. Yeah. So one of the reasons is like as Spark the default file format for Spark is Parquet, and it supports the read of the data very properly. So reading is very efficient with Parquet, and since it's used for analytical purposes, so it's like one of the best choices to use. And yeah, it also has various compression techniques
Yeah,
which allows which saves time
yeah,
to for processing the whole ETL pipeline per se.
yeah,
Yeah, and it also has, like, since you said like CSV and JSON, they are like semi-structured files, so not good for like you can have like small experiments on that, but yeah, to run the ETL pipeline, it's not the best choice.
yeah.
So in your jobs, like what you have run so far, have you used cache or persist?
Uh, I have used cache in the jobs I have run specifically. And my major usage of cache was basically because I wanted to retrieve results faster. And I
Mm-hmm.
knew that the data that I was dealing with wasn't too necessarily large. So it could be fit into the memory of whatever executors I had while I was running it in the interactive mode and
Mm-hmm.
retrieve the results fast. Yeah, I haven't extensively used disk as such, but
Mm-hmm.
yeah, I'm aware of, whatever storage levels and whatever persistence levels are present with disk as well.
Okay. So you mean to say cache and persist, like both are same, but like they both are used to store data. Like one is cache is mostly used to store data in memory, and persist, like it comes with various storage options, like
Yes,
off, like in disk, in memory, off heap.
yep,
Like, got it. So, okay, let's dive into some coding questions.
sure,
If you can share your screen.
yeah,
Yeah, so there is a string called, suppose, string. So S is a string.
yeah.
This is the input, and I want an output like this, where like it will this is a like program, like you can choose your own language, Python or whatever you're comfortable with. So like while iterating this particular string, so whenever it notices an I in the string, so it should reverse the previous part of the string. So for example, sorry. So for example, here you have stri, so it should be like RTS, and then I won't be there in the string, and then you give me ng.
Okay.
Okay,
So
so
for
yeah, tell me.
fine. For every I that you encounter, you kind of reverse the string, the substring that is previously part of the string, right?
Correct, correct.
Okay. Yeah, sure. So let's consider shall I? Let's consider that we have this string, as you mentioned, string. I'll take this example for demonstrating the first.
Yeah.
Yeah. Now, what we could do is we would obviously be iterating over this string, and we would kind of make a note of the first I, the index of the first I.
Mm-hmm.
So essentially, suppose, yeah, 0. In this case, the index of the first I is 3, and we've iterated from 0. Uh, so once we come across the first I, what we could do is, yep, okay. So we could, to begin with, we can have a blank string, and we can concatenate all of the entries. So suppose when we are iterating over the string, we come across the first I at the position 3. Then we know that from 3, 2, 1, and 0, we have to concatenate all of these in W. And
Mm-hmm.
essentially, W will then become RTS. And since now we've encountered I, we would yeah, proceed in a similar fashion till we encounter the next I and do the same thing. For example, if we had a string here as well, I suppose ty or something.
Mm-hmm.
In the second iteration, when we encounter this I, in a similar fashion, we would gn, and then for the remaining remainder of it, we don't have any trailing i's. So what we
Yeah,
could do is we could just iterate till the last I that we encounter. And for whatever part of the string is remaining, we can just directly append it to the string that we are dealing with.
got it.
So, yep. I'm trying to formalize this. Or maybe what we could even do is we could probably convert this string into a list basically. For example, if we have S, T, and so on and so forth.
Mm-hmm.
Yep. And this would probably be faster than directly appending to this thing. For example, what we could have is, suppose if we identify the first I at position 3, we would essentially have uh, 0 to 3, sorry, and we would reverse it.
Mm-hmm.
Yep. So this is the part of the string that we are reversing, and this is over here. And we could, yeah, we could probably store this in some array or something. And then that array, again, till we, and then we identify the second I over here. And to this array, we kind of append this thing, the second, the N and the G thing.
Mm-hmm.
And whatever is remainder, whatever the remainder is, we can directly add to it. And then maybe, again, join it in order to get the final string. Is what I,
Got it.
yep,
Yeah, yeah, you're pretty close. So, like if you can open your Google Doc.
yep, sure.
Yeah. So, think. Um, second. Yeah. So this is what I was looking for. But yeah, the logic that you said also works.
All right.
Uh, yeah. So like as you said, you would put it like you would take the string into array and then you would
Yeah,
parse it through and append. It will still work. Like you are appending it to the string, and then when like it encounters I, like till it encounters I, it would append, and then when it encounters I, it would just reverse and then keep on going.
yeah, that makes sense. Okay. Okay. Yeah.
I'll give you another one that's an SQL question.
Sure.
So, for example, sorry, just a second. So, this is a table called activity, and you have this particular columns. Um, I'll give you some sample data. Which looks like this.
Yep.
Mm, yeah. So this is the sample data. My output should look like so my output should sorry. My output should look like this. So basically it's calculating. So you have one table called activity. It has machine ID, process ID, and the type of activity.
Okay.
Mainly the activity start and end. So you would calculate the activity time, and then you have to calculate the average time of each machine.
Average time of each machine. So, what I firstly noticed is, for example, if you have machine ID 2, you have two process IDs, and I think the same trend is there for every machine ID.
Yeah.
So, you expect the average across all these process IDs, is it?
Yes.
Okay. Can I just do a calculation myself in order to understand the output?
Okay, so I can give you sample example.
For this case, what we could probably do is we can firstly order this. Sorry, we can partition by process ID and then we can order by the activity type in the descending order because it's alphabetical. End would be first, so we will probably go with the descending order. So what we will have is for every partition, we will have uh, yep. And then what we could do is or else what we can directly do is yep, what we can I think we can do without partitioning itself. I think wherever we encounter start, we put a -1. So what essentially we will have is we will have a -1 wherever the start is, and then we will group by the machine IDs and the process IDs and calculate the sum firstly of the activity of the timestamps. So what we expect is we expect something. I'm sorry. We expect something like 0, 0, and then this thing 1.52 minus 0.712,
Mm-hmm.
and then we'll have 0, and then 1, and then 4.12 minus 3.14. So essentially, once we have for every machine ID and every process ID, we will have the difference of the timestamps because we've kind of put -1 against the starts. So yeah, we'll have this time. And then we can ignore the process IDs and just directly, just directly take the average of this thing
Yep.
for every machine ID. So we'll have 0 and then the average of this thing, which is uh, mentioned over here.
Yeah, yeah, that's right. You can go ahead with the coding.
Yep. Yep. Can I continue coding here itself?
Yeah, yeah, no problem.
Okay. Let us call it P dot machine ID. Process ID. Activity. Okay. Select. Oh. Yep. So I'll just explain the query. So what I've done is, firstly, in the first common table expression, I have put a -1 against activity types where the activity type is start and stored it. And then this is a second common table expression which I've used because we are storing intermediate results again. So in this one, what I've done is grouped by the machine ID and the process ID and did the sum of the activity type, the new one, which I which for which the start is -1 and the end one is as it is, and stored it as temp sum, wherein I have grouped by the machine ID and the process ID. And lastly, once we arrive here, we probably don't need the process ID. So just group by the machine ID and you calculate these sums and you just divide it by 2 in order to arrive at the final average.
Yeah, got it. Yeah, yeah, that's correct. So there was like what you explained or like how you did that, that's absolutely correct. It's one way of doing. So you you could have avoided common table expression like using the case statement, like and doing the sum, like you take the timestamp of the end as plus and then timestamp of the start as minus. So like if you add, you'll get the time difference, and then you can average by the count of the process ID.
Okay, even that makes sense. Yeah.
Yeah.
Yeah, I'll acknowledge it. Yes, yes.
So yeah,
Yeah.
like but if it's like also depends on the size of the data. So if there are like millions of rows, then your CT approach would be better.
Okay.
Like the way you did. But other than that, like if to make the query simpler or like to make it in a more understandable way, the process that I explained, that also works. But
Yeah,
yeah,
sure.
thank you for this one. Yeah, a complicated one, but it's acceptable. Yeah.
Okay. Thank you. Thank you so much.
Yeah. So yeah, I think I'm done. I'm done with the interview. Thank you a lot, Aziz.
Thank you. Thank you so much, Pio, for your time.
Yeah, sure. Yeah.
Really appreciate it. Thank you so
Yeah.
much.
Yeah. Yeah. Bye.
Bye.